Hey everyone, today we're going over Module 1, Chapter 1, which is Thinking Critically. So our first problem here, we have a puzzle. And our numbers to this puzzle are 8, 10, 11, 12, and 13. And what we're going to do is we are going to add the numbers together so that whenever we have the row here and the column, the row and column, the sum should equal 31. So I did place 8 as our center number, and the way that we would start by working this is actually by just plugging in the numbers. So we have 8, of course, is going to be our starting number. So let's do 8 plus 10 plus 11 equals what? 21. So that is not 31. So what we're going to do is just take out 11 and we're going to make it 12. So that will give us 29. And I'm of course just dropping these down. And then if we did 8 plus 10 plus 13, that would give us 31. So that is what we are looking for. So we would just add in here 10 and 13. And so that I don't get myself confused, what I would do is just cross off 10 and cross off 13 because you can only use each number one time in the row or column. So our next numbers, or we want to make sure that we're utilizing all of our numbers. So if we reuse a number, multiple numbers, then it's not going to work. Our problem isn't. So moving along, what numbers are left? Of course, 8, which we're going to use. And we have 11 and 12. So does 8 plus 11 plus 12 equal 31? Yes, it does. So we can just add in here 11 plus 8 plus 12 equals 31. And we've now solved our problem using critical thinking. So here we're going to be using a tool called perimeter. The perimeter is the area here on the outside of the object. The area would be the inside. So perimeter would be like the fence around the yard, and the area would be like the area that your dog can run around inside the fence. So what we're doing is trying to find the perimeter, which it would be like the fence. So let's call this feet, these units feet. So let's say we should use 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 1 plus 9 plus 1. So that would equal 20 feet. So the way that I did that, to find perimeter, it's your formula every single time. It's all of your sides added together equals the perimeter. So all of these together, if we were to work each of them out, our numbers are going to vary between 20 feet and 13 feet, all of them except for one. Can you guess which one? It's this one here. So it has 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 3 plus 3 plus 3 plus 3 would equal 12. 12 feet in perimeter. So this is actually our smallest perimeter on our whole chart here. So moving along, I have here different what is starting. We start with just one dot, and then we move on and we have 5 dots. And I see 1, 2, 3, 4, 5. It awfully looks like a pentagram. Pentagram has 5 sides. So we are going to take a look at it, and do we notice a pattern other than that I can't put dots on a PowerPoint? So our pattern is that how we got this second number here, the purple and then the blue, is that we actually add 3 to the original number, and then we add the original number plus the number that we created. So 1 plus 4 equals 5, and then 1 plus 4 plus 7 equals 12. So 1, 5, 12, and if we just kept going, that's supposed to be 22, 35, 51. So that's all fine and dandy. Except, what if I asked you, what would be our maybe 9th figure? If I were to, keep placing dots on here, what would our 9th figure be? So there's actually a formula for it, and the pentagonal formula is N for number, open parentheses, 3N minus 1, close parentheses, all over 2. So if I'm wanting to find the 9th figure, the amount of dots that I would have to place, it would be 9, open parentheses, 3 times 9 minus 1, close parentheses, all over 2. So I can use my calculator to save us some time, and I can say 9, open parentheses, 3 times 9 minus 1, close parentheses, and that gives me 234, and remember it's all over 2, so divided by 2 is 117. So different ways that I could have done that. I could have, if someone said, well, what would your 9th figure look like? I would just keep, how many dots would you have placed? Well, I could just sit there and, put them all out and count them as I did it, or I could just use that formula. Well, what about the 10th? Let's do the 10th. So 10, open parentheses, 3 times 10 minus 1, close parentheses, all over 2. When I say all over 2, I mean divided by 2. So again, we can just plug it into your calculator. So 10, open parentheses, 3 times 10 minus 1, close parentheses. So 290 divided by 2 is 145. So that is correct. So 145. Okay, so I see here that I did go ahead and put our numbers here, and it shows the corresponding that, we did add 3 each time. And if I wanted the 10th, then this is what those numbers would be like. So these numbers here, of course, we start with the 1, and then I have 4. So each number in that row there, I'm sorry, in that column, and each column signifies, I changed, of course, the color that helps, you know, the visual, and that's what those would be. So I would have 28, whatever color, on the most outer edge of 145 dots. So moving right along, here we have another puzzle, as I'll call it. And if I take a strong look at this, I see that 3 plus 5, maybe we can change our color here. 3 plus 5 equals 8, and 5 plus 4 equals 9. And then 8 plus 9 equals 17. So if that's our pattern, that each of these equals the one directly above it, if that's the pattern, then let's take a look at this one down here at the bottom. So I see here that we have 7 plus 3, so 7, 8, 9, 10. So I'm still missing some here. So what I could do is say, I know 25 minus 10 equals 15. So 15 may work here, right? So let's say 15 minus 7, and that would give me 8. So I could say x is equal to 8. And if I wanted to check myself, then all I would need to do is just add, of course, this box with this box to make sure this one clicks here, and so on and so forth. Let's try maybe some more difficult ones. So I think I should maybe change my marker back to this green. So I have here, we're missing 3 variables here. So I know that y plus 2 equals something, and y plus 1 equals something, and all of it together equals 15. So if I was to write an equation, it might look something like this. To me, this doesn't look as scary as this blank chart here. So what I could do is actually combine some terms, some like terms. So I see that y and y are the same variable, so I can combine them. So I have 2y plus, I have 2 and 1, which makes 3 equals 15. And from here, all I would do is just work backwards. So I would minus 3, subtract 3, that cancel this out, and that would make 12, and 2y. And so from here, we would just divide, of course, 2y by 2 to break that 2 away from the y. And then that would give us y equals 6. So if I plug in 6 right here, 6 plus 2, 6, 7, 8. and 6 plus 1 is 7, and 7 and 8 added together does equal 15. Moving on to a bit more tricky one, I would essentially do the same thing that I did here, and I would find that z is actually equal to 10. And if z is equal to 10, then I would need to, of course, then just work backwards. So 27 minus 10 equals 17. And then 17 minus 9 is 8. And I see that 8 plus 2 equals 10. So this all checks out to me. Moving right along, I see here we have a chart. And this is kind of like a riddle. And on this riddle, we have up top here some ladies' names, and these are wives. And on the side here, some gentlemen's names, and these are going to be the husbands. So we're just going to read through this and see if we can figure out who is married to who. So Floyd is Josie's brother. So if Floyd is Josie's brother, then they can't be married, right? So let's say Josie and Floyd, let's put a big ol' X here. So we know that they cannot be married. Okay? Josie and Gus dated some, but then Gus met his present wife. So we know that Josie and Gus dated once before, but they did not end up getting married. So he's married to someone else, Mr. Gus is. Kitty is married to Will. So Kitty and Will are married. So let's put a nice check mark there. So whenever we get a check mark, we want to make sure that everything associated, all of the possible boxes, are X'd out. That way it helps us with our process of elimination. So I crossed out all of Kitty's other than the correct one, and all of Will's other than the correct one. So I see here that Miss Josie only has one box left, and that's Mr. David. So we can go ahead and put a check mark there. And that means that we can put an X for here and here. And see, now all we have to do is figure out Sarah and Ann and Gus and Floyd. So let's continue to read. So Ann has 2 brothers. So Ann has 2 brothers. So we already have 2 people checked off that they could not be. So that still leaves Floyd or Gus. Ann's husband is an only child. Okay? So if Josie is Floyd's sibling, then that would make Floyd not an only child, right? So let's put an X here, and that would tell me that Gus is Ann's, and that would mean that we would have Will and Kitty would be married, Sarah and Floyd, David and Josie, and Ann and Gus. And then all of our chart is filled with either a check or an X. So we are complete. So here we have, excuse me, here we have some dots, and these are going to be our trapezoidal numbers. So if you ask me, what is the trapezoidal number for these? Excuse me. The trapezoidal numbers for these, I would look at it and go, what the heck? I don't know. You know, it's going to take me forever to count those. but it would help me if I maybe rearranged these dots. So that's what I did here, is rearrange them into rectangles, because if I take these rectangles, then I can say I have one row of 3, so 1 times 3 is 3. Going forward, 2 times 4 is 8, and 3 times 5 is 15, and 4 times 6 is 24. So each of these numbers here would be my trapezoidal number for each figure. So that's all I have for us today, guys. I hope you have a great rest of your evening.